Hi, boys and girls. Today we're going to spend a little time discussing in more detail something known as the octet rule. The octet rule tells us that atoms will gain, lose, or share electrons so that they end up with 8 electrons in their outermost electron shell. All right. And I think the best way to go about doing this is just to go ahead and talk about the noble gases on the periodic table, because the noble gases have as one of their characteristics is that they are chemically unreactive, and the reason they're chemically unreactive is that they by themselves they don't have to gain, lose, or share any electrons, so they don't have to react chemically. They already satisfy this octet rule. They already have 8 electrons in their outermost electron shell. So let's just take a look at the electron configuration of neon. Right. Neon has 10 electrons. Now, if we remember this diagram, our Aufbau diagram, it tells us the sequence in which electron orbitals fill. We start with the 1s and then go to 2s and then 2p. So this is where we're getting this from. 1s2, that would be 2 out of the 10 electrons, and then 2s2, that's 4 out of the 10, and then 2p6, that's all 10 electrons for neon. However, the outermost shell, that's where n is equal to 2, all right? So the 2s's and the 2p's are all filled up. There's 2 here and 6 here. That gives us a total of 8 electrons. We could say that here's neon's octet right here. Right? The 2s2, 2p6. Neon has an octet. Neon satisfies the octet rule. It doesn't need to gain, lose, or share any electrons to get an octet. And again, as I said, neon's a noble gas. One of the characteristics of noble gases is they don't react chemically with other things. And this is the reason why. Let's go ahead and do another. Let's try argon. Okay. What or how can we show that argon already has an octet? So if we look on the periodic table, you see that argon has 18 electrons. Okay. Where's the first 2 electrons go? Well, it goes in the 1s orbital. So it'd be 1s with 2 electrons. And then after that, we go to 2s. That's also, s's hold 2 electrons. And then 2p. P orbitals hold 6 electrons. And then we go to 3s. 3s2. All right, that's a total of 2, 4, 6 makes 10, and 12. All right, so we need to add, what, 6 more? And after the 3s goes 3p. 3p6. So there's all 18 electrons, 2, 4, 10, 12, 18. And the highest energy level, n equal 3, has 8 electrons. The s's hold 2 and the p's hold 6. We're going to see this over and over and over again. An octet is represented by a full set of s and p orbitals. Okay, so we would say that argon has 8 electrons. It has an octet. Okay. Now, here's really the meat of today's discussion. What do we do with the other elements, or how can we maybe predict what they do chemically, right? Because all the other elements on the periodic table, if we take the noble gases out of play because they already have octets, they're not chemically reactive. All the other elements are chemically reactive. And what we're saying here is that we can predict a little bit about how they're going to react chemically by following the octet rule. For example, let's take fluorine and check out its electron configuration, and then we'll discuss what we see. Okay. So, fluorine's got 9 electrons. Fluorine, 9 electrons. So that's 1s2, 2s2, 2p5. All right. The outermost energy level is where n is equal to 2, so that's the 2 s's and the 2 p's in this case. That is not an octet, that's only 7 electrons. Okay. There are 7 electrons in fluorine's valence. The outer electrons are called valence electrons. So we say there are 7 electrons in fluorine's valence shell. Okay. How does it achieve an octet? All right. Fluorine with 9 electrons has this configuration. There's only 7 valence electrons. How does it achieve an octet? Well, obviously an octet being 8 electrons, we only need to add 1 electron to fluorine in order for it to achieve an octet. Well, if an atom gains an electron, we then call it an anion, a negatively charged ion. Right? And in this case, we would say a fluorine 1- ion forms. Okay. This ion contains 10 electrons. Right? Now, if we look at the periodic table, we see that there's already an element with 10 electrons, all right, neon. And we've already said neon is an element that already has an octet. We're going to see this over and over, that if we pay attention to the location on the periodic table of an element and just count how far away from the noble gas column it is, we could say something about how it gets an octet. Fluorine achieves an octet, or an electron configuration similar to neon, by gaining 1 electron. We would say, and we'll see this in a bit, oxygen is 8 electrons. How does it achieve the same electron configuration as a noble gas, which we know already has octets? Well, oxygen has 8 electrons. To have the same number of electrons as a noble gas, the nearest noble gas, would have to gain 2. But we'll come back to that. Okay, this ion contains 10 electrons. So that's 1s2, 2s2, 2p6, that's 10 electrons, 2, 4, and 6 is 10. And there's our octet. All right, bam. So what does that mean for fluorine? Fluorine atoms are chemically reactive because they do not have octets, whereas fluorine anions, an anion is just a negatively charged ion. If this were a plus, then we'd call it a cation, but fluorine -1 anions are stable because they have an octet. Okay. Now, let's do the same thing, as I said, for oxygen. Right? If I just out of the blue said to you, is an oxygen atom stable? You would say, okay, by stability we mean what is its electron configuration, and more specifically, does it have an octet? Are there 8 electrons in the outermost energy level? So oxygen has 8 electrons. All right. And what is the configuration for 8 electrons? Well, we start with 1s and then go to 2s and then 2p. So let's fill those up. 1s holds 2, 2s holds 2. That's 4 electrons, so we have 4 more. And the p's could hold up to 6, so we could fit 4 into that easily. This right here, where n equals 2, is your valence shell. All right. And how many electrons do we have, or how many electrons does oxygen have in its valence shell as an atom? All right. There are 6 valence electrons in oxygen, in an oxygen atom. Okay. Now that obviously is not an octet. Right? To achieve an octet, oxygen needs to gain 2 electrons. Right? We said up here that it has 6 valence electrons. An octet's 8, so how do I get to 8? I need to gain 2 electrons. All right, so if we go back up to the original, if oxygen, which originally has 8 electrons, gains 2, it'll go up to 10 electrons. And as we mentioned earlier, 10 electrons is very similar to the electron configuration of neon, which we know the noble gases here are unreactive because they already have octets. So it's not surprising that oxygen, which has 8 electrons, is going to gain 2 electrons, because in doing so, it ends up with the same number of electrons as the nearest noble gas, neon. Now, a point here, oxygen doesn't become neon, right? Oxygen just ends up gaining 2 electrons so that it has as many electrons as neon. Oxygen becomes, in fact, an oxygen minus 2 ion. If I'm gaining 2 electrons, then the O goes from being a neutral atom to being a minus 2 ion. So when oxygen gains 2 electrons, it becomes O2 minus, an anion with a total of 10 electrons. Again, oxygen starts out with 8 electrons. It gains 2 to have 10 electrons. So O2 minus has the configuration 1s2, 2s2, 2p6, 2, 4. That's 10 electrons. And here is my octet. Whereas the oxygen atom, the neutral atom, had 2 fewer, right? It was just O with 4 electrons here. When I gain 2 electrons, this goes up to this, and 2 and 6 makes 8. That's an octet. Okay. Now, let's just do one more here, and then I'll give you your assignment for today. How about something like sodium? All right, sodium has 11 electrons. Na, sodium has 11 electrons. All right. So that would be 1s2, 2s2, 2p6, 3s1. Right? 2, 4, 10, 11. That's the correct electron configuration for sodium. Notice here, the valence shell is where n equals 3. The highest principal energy level, or the highest shell. Not orbital. The S's and the P's are the orbitals. The shells are the 1s, the 2s, and the 3s. The valence shell is the highest one, so n equals 3 in this case. Okay. Now, how could I get an octet around this sodium? All right. Well, as it turns out, metals, which are the, there's a little line that goes through the periodic table like this that separates the metals from the nonmetals. We're going to find that the metals lose electrons in order to achieve octets. So if I were to lose one electron, right? Lose the 3s electron, what do I end up with? Well, the sodium atom now becomes a sodium plus 1 ion. If you're losing an electron, you're losing negative charge, which means you become positive. All right, so the sodium becomes a plus 1 ion with not 11 electrons, but 10 electrons. And we've seen this before. 10 electrons is the exact same number of electrons as the noble gas neon. So notice sodium, although it's way over here on the other side of the periodic table, the nearest noble gas to sodium is in fact neon. Now, if I like to do this with my students. If I were to just take a regular periodic table and just do a little bit of folding, let me fold this around this way, and then the other side of the periodic table, I'm going to sort of fold back around on itself. Notice sodium, which is right here, all right? Sodium number 11, all right, is closest in atomic number to the noble gas neon. All right, so we're always going to go up a row because we're losing this 3s electron. And we're sort of backing up on the periodic table. Okay, so the sodium plus 1 with 10 electrons has the configuration 1s2, 2s2, 2p6. And here's your outermost shell now. All right, we lost the 3s electron. So now what we've done is uncovered, you might say, the inner n equal 2 orbital or energy level. And the 2s and the 2p's give us a total of 8 electrons, which is my octet. Okay, so I hope that's a sufficient explanation for what I'm going to now assign to you. What I want you to do is tell me exactly how these next few elements, how do they achieve an octet? It's either going to be by gaining or losing electrons. We'll talk about the electron sharing later. Right now we're interested just in how many electrons does this lose or how many does it gain in order to get an octet. So how many electrons must be gained or lost by the following to achieve an octet? Now let's see, we did fluorine already, we did oxygen, we did neon too, we did sodium, so let's try magnesium, Mg, all right, we'll do that one. Let's go on and do Al. Now a little hint for you here, metals like magnesium and aluminum will lose electrons, right? The non-metals, the guys up in the upper right hand corner, the ones that are above this stair-shaped line, the non-metals will gain electrons, unless they're noble gases, in which case they don't gain or lose anything. And so let me ask you, let's see, sulfur, we'll do sulfur, and chlorine, and let's do argon, all right? And let's throw a few others in there. Let's do rubidium. And we're going to have to skip the transition metals. All right, remember, the transition metals are the D block elements. And the electron configurations of the D blocks make it a little bit harder to analyze. We want to stick with the main group elements, the first 2 and the last 6. They're easier problems to do. And let's do, let's see, iodine. So there we go, boys and girls. Magnesium, aluminum, sulfur, chlorine, argon, rubidium, and iodine. All right. I'll print this up as a worksheet for you so you don't have to worry too much if you don't catch it here on the video. But what I do want you to do is write down the original electron configuration as an atom. All right. So for magnesium, which is element number 12, you'd have to write the configuration that includes 12 electrons here. All right. Then just looking at that original configuration, figure out how many electrons, the number of electrons lost or gained. And then the new electron config. All right. Just as an example, let's go back and put in what we did for sodium. So I'll put sodium down here at the bottom. All right, Na. The original configuration was 1s2, 2s2, 2p6, 3s1. We're going to lose one electron, and that means we're going to take this guy out. So it'll be 1s2, 2s2, 2p6. All right. And one last row, right, will be the symbol of the ion formed. So the symbol of the ion formed. Like I said, I'll write this up as a worksheet for you. And that'll be it for today. Yeah, that's it.